Welcome to Study Loop.
For this problem on the topic of waves and sound, we are given the temperature on a day when a truck is traveling at constant speed and it passes by. After a given time elapses, we use an ultrasonic ruler to measure the distance to the truck. We receive a sound pulse a given time later, and if we are given the average molecular mass of air as well as the constant gamma, assuming air is an ideal diatomic gas, we want to determine how fast the truck is moving. Now, the speed of the truck we'll call Vt is equal to the distance x it travels divided by the time it takes to travel that distance. So the speed of the truck we'll call Vt, and this is equal to the distance it covers x in the time it takes to cover that distance, Tt. We'll call this equation 1. Now, we know that sound also moves at a constant speed, and it travels the same distance x in reaching the truck. So again, for sound, that distance x is equal to the speed of sound v times the time that sound takes to travel that distance, ts. But the time for the sound to reach the truck is 1/2 of the round trip, which we'll call trt. So we can write this as v times 1/2 of the round trip time for the sound to reach the truck and reflect back to the ultrasonic ruler. So we can write this as x is equal to v into 1/2 trt. And if we substitute this expression into equation 1, we get the speed of the truck vt, which we said was x divided by tt, we can write as v into 1/2 times the round trip time divided by the time of the truck, tt. We'll call this equation 2. Now, since we assume air is an ideal gas, we know the speed of sound is related to the Kelvin temperature and the average mass of a single air molecule as follows. So V, we know, is the square root of gamma times K times T over M. And so gamma is the ratio of the specific heat capacity of air at constant pressure to constant volume. K is the Boltzmann's constant, and we know T is the temperature. So if we put this into 2, we get the speed of the truck, Vt, is equal to the square root of gamma times K times T over M multiplied by 1/2 times the round trip time, TRT, all divided by the time of the truck, TT. Now, from this equation, we can see the temperature here, it needs to be in Kelvin. So we have the temperature in Celsius, so T is equal to the Celsius temperature plus 273, which is 56 degrees Celsius plus 273, which gives us the temperature in Kelvin of 329. We have the average mass of an air molecule is given to be 4.8 times 10 to the minus 26 kgs, which we found in the example. So therefore, the speed of the truck, Vt, is equal to the square root, gamma is given to be 7/5 for a diatomic ideal gas, times 1 that's 7/5 times Boltzmann's constant, which is 1.38 times 10 to the minus 23 joules per Kelvin. multiplied by the temperature T, which is 329 Kelvin, divided by the mass of a single air molecule, which is 4.8 times 10 to the minus 26 kg, and this is multiplied by a half times the round trip time, which we know is 0.12 seconds, and this is all divided by the time of the truck, which is 4 seconds to travel the given distance, and so we get the speed of the truck Vt to be 5.46 meters per second.